Hello. In this series, I'm going to be showing you how I built my procedural world generator in Godot so you can use it in any project you like. In this video, I will be doing a broad overview of the world generation system so that for those of you who know what you're doing, that might be enough to help you build your own world generation system. But starting in the next video, I will dive into all the code for every step of the world generation system. It's based on the procedural biome video I made recently. In that video, we made a biome generator that sets the biome colors based on a rainfall map and a humidity map, which are just two different noise functions. And then we use a subviewport in our scene to save several images of the biome map, with each biome assigned to a certain color channel so that we can easily find the weight of a given biome at any world coordinate later on. So today we are jumping off from there, as well as using a clipmap system based on DitzyNinja'sGodojo clipmap and collision system. His video is linked right here. So the way our world generator will work is by using a combination of some noise textures and masks. We will generate a random height map for our game world, saving the image using the subviewport method of saving shaders as images. I have another video explaining only how to do that, linked right here. Then, to add some variation and customization to make the world a little bit more interesting, I would like to generate some mountain ranges that spread across the world on fault lines. These fault lines will just be linear gradients with some curve and noise applied that will be used as a mask for mountain range and rolling hills textures, which again are just noise textures. And then we will need to generate our procedural biomes with an upgraded version of the biome generator from my previous video. In this new biome generator, we now use this height map as well to generate an additional 5 altitude-based biomes, which are ocean, which appears below sea level, beach, which appears just above sea level, and then for higher altitude biomes, we have alpine grassland, alpine tundra, and alpine desert. Also, besides just saving images for the biome weights, we use this biome generator to generate a few new masks that will be useful later, such as a water biome map, which uses one water biome per color channel, so red is wetland, green is swamp, and blue is lake. Our swamp mask, which is just a mask with swamp regions isolated for us to use to apply the swamp texture. Wetland mask with the wetland regions isolated for applying the wetland texture, and then the lake depth mask, essentially using the original noise from humidity and rainfall to create a depth gradient where there is a lake. So after all these images are generated, I wanted to see if I could design this so that lakes and bodies of water can appear at different altitudes. If you want lakes, rivers, or ponds at different altitudes than your ocean, you have to either place them there yourself or figure out a way to put a body of water there algorithmically. The other alternative is to just have any lakes or bodies of water at all be at the same altitude as the ocean, and you can just use the ocean water plane for all bodies of water. And then of course you can just omit water biomes altogether. So my idea for doing this is to use my water biome map to identify all connected water biomes of any type and group them together. Then for each individual water region, which represents where a water plane should eventually be, we get the average altitude of our original height map in those regions and flatten the entire terrain in that region to the average altitude. Then we will use the lake depth mask we created with the biome generator and subtract the lake depth from the flattened regions to make the lakes. Then we will use the swamp mask and wetland mask to overlay small detail wetland or swamp terrain textures onto the flattened regions. That way, a single water plane can be laid down at the average altitude calculated earlier, minus a few meters, and you end up with lakes and swamplands. So all this will result in our final height map. With all steps working, I use a clip map I created in Blender and add some collision and set it to sample my final height map so I can finally run around in my game world. The next step is to increase the scale and resolution, so instead of using a single image for our entire world, we can split the world into tiles and sample the correct UV coordinate at the correct tile for any given world coordinate. The more tiles or image resolution we have will exponentially increase the time required to generate our world, but the Clipmap system can handle a good amount of images with decent performance. This tiling system mostly entails generating texture 2D arrays with all the image tiles instead of just image textures. This means you also have to now sample the texture arrays instead of just a single texture. This is really simple to implement and it is very rewarding. So after that, I'll show you how I got the tiling system working with my clipmap and collision system. This involved implementing a custom bilinear interpolation function into my collision system to accurately sample the terrain. So that was an overview of the entire world generation system. In the next video, we will go through the code for every step of the world generation process so you can see how to go from nothing to having a simple procedural world generator. If you would like to support this work and help me make more of it, feel free to buy me a coffee on ko-fi.com. And if you wanted to support me further, I now have a Patreon where I will be releasing videos early before they appear on YouTube. As always, the code for this project is on my GitHub. Due to the size of the project, I decided to just host the code for the scripts and shaders because the scene setup is fairly simple and will be explained in detail in the coming videos. Thanks for watching, and stay tuned for part 2 of the Procedural World Generation series.